I've been privileged to be a part of several of these so far. Selena, is there anything you wanted to add this morning?
Yes, I wish we were in Austin, Texas.
Me too. Me too.
But good morning, class. Today we're doing 1 and 2 family dwellings based off of the 2018 IRC with Keith Laughlin as your instructor. I just want to make sure that everyone has received their download material that came from IAEI. So that was sent to you. And some of you a couple of times, but if you want to chat me just to make sure that you have that download so that you can follow along for the class today. Just a few housekeeping things. Make sure that you keep yourselves on mute because your background noise does pick up. And there is a leave button at the bottom of the screen. Don't press it because you're going to be put in a waiting room and we physically have to be looking at the screen. With Keith, it's hidden, and then I work throughout the day, so I'm not really looking into your class as much as you think I am. But it just makes sure that you're not leaving. Of course, if you have audio issues, then disconnect. But I know I've been pushing that button several times a day. And if, I don't want to walk away for a second and have you in a waiting room and miss any of the class. So you can leave if you need to, turn on and off your camera. Keep your mics muted, but don't press that leave button unless you're physically getting kicked off of the meeting. But that's all I have to say, Keith, and you can go ahead.
Okay, as I said, my name is Keith Laughlin. I'm the Director of Education here at IAEI, International Association of Electrical Inspectors, and we are honored and privileged to team up with ICC on these residential inspection institutes. I was the chief electrical inspector in the Dallas-Fort Worth area for 20-something years before I went to work directly for IAEI. I serve as chairman of Code Making Panel 7 for the National Electrical Code. There's 18 code making panels. Those code making panels looks at the public inputs that are submitted to get changes to the code. And I have the privilege of serving as one of the chairman of one of those 18 code making panels. The presentation we're going to use today comes out of a book that we publish here at IAEI. IAEI's 1 and 2 family dwelling electrical systems. And I have had the privilege of being the author of that presentation, that textbook for the last 5 code cycles. There's the cover right there. This is a unique book in that it addresses 2 different codes. Not only is it based on the National Electrical Code, but it also has information and code references and illustrations based on the International Residential Code as well, which ICC publishes. Part 8 of the ICC covers electrical requirements. And we'll take a look at that here in just one second. When I build the PowerPoint for this presentation, I actually build 2 PowerPoints, one based on the NEC and then one based on the IRC. And of course, the one we'll use today is based on the IRC. Now, when you start dealing with the electrical requirements of the IRC, you have to kind of set some parameters or ground rules here. And like I said, part 8 is where the electrical requirements are found in the IRC, beginning with chapter 34, goes through chapter 43. And I wanted to highlight this first sentence right there. I'll blow it up where we can read it there. These parts here, the electrical parts, are produced and copyrighted by the National Fire Protection Association. Now, the reason I bring that up is that's the exact same people that write the National Electrical Code, own and copyright the National Electrical Code. So what I'm saying here is that, a lot of times people will look at the IRC, part 8, and that's one electrical code and the NEC is another electrical code, which it is, but it's all the same material basically. And it's written and produced by the same people. And then right down here, let's look at this right here, where it talks about that these chapters, and it even says that the electrical provisions of this code are identical to the intent of the NEC provisions. And it also talks about if a part, if we come across something here in the IRC that is not covered in Part 8, especially right there, it tells us at E3401.2 in the scope of the IRC that when we come across something in the IRC that is not particularly covered by the IRC, we can't just ignore it. We have to default to the NEC. So, if you were to get into, let's say, the IRC will address an electrical service up to 400 amperes. Well, if you got into a large dwelling unit where we got into a size larger than 400 amperes, then we would default to the NEC. And you'll see several places as we go along today where we would have to default to the NEC, and of course I'll point those out to you as we go along as well. And by the way, we will take a couple of breaks this morning. I don't want to try to make you sit here for long stretches of time. So hour and 10 minutes or so, we'll take about a 10-minute break. Rather than take one big long break, we'll take a couple of 10-minute breaks. I'll even put a timer up on my screen that will help you get back to your computer in a timely manner. And we'll go with that. I often hear, and I suspect greatly that I have several combination inspectors on the line with us today. And if that's true, of course, you have to be prepared and enforce several codes, not just one code, the mechanical code, the electrical code, building code, and so on. And especially when I'm doing a class with combination inspectors, I often hear that of all the disciplines that you have to enforce, again, plumbing, electrical, mechanical, building, that you typically have the most difficulty with the electrical code, and that there's gray areas in the code, and that's really not a mistake. It's not. It's by design, actually. And so yes, there are gray areas in the code, and we need to address them. And an example of that I could give you here is here at E3601.6.2. Now that's 23070A1 in the National Electrical Code. And again, by the way, over the years, I've learned the hard way. I learned that whenever I'm teaching a class based on the IRC, especially when we were meeting in person, every slide that came up, someone would raise their hand and say, "That's great, Keith, but where do I find that in the National Electrical Code?" And so every slide that we're looking at today, the IRC reference is going to be up here in the title, but down here in the corner, you're always going to see the NEC code reference that addresses the same subject matter. But when we look at this section right here, it deals with our service disconnecting means. If you're going to have electricity in the building, you're not required to have a service, but But if you're going to have electricity in the building, then yes, you're going to have a service. You're going to have a service disconnecting means. Now, the location of that service disconnecting means, E3601.6.2 here tells us that the service disconnecting means must be located on the outside of the building. And then the biggest word in the entire code book. It is absolutely the largest word in the entire code book, or, or it needs to be located inside. But if it is inside, your service disconnecting means it has to be located nearest the point of entrance. Wow, what does that mean? How far is nearest the point of entrance? That's one of those gray areas in the code. If you ask one person, they're going to say, oh, that means, just back to back, or that means 3 feet or 4 feet or 6 feet or whatever it is. And who's going to determine what nearest the point of entrance means? Now, we're going to use this term all day today. The person that would determine what nearest the point of entrance means here is, of course, the authority having jurisdiction, the AHJ. That's a defined term. It's the person that is, or the entity, the department that is responsible for enforcing the electrical code in your area. The electrical inspector, the building official, the fire marshal, whoever that might be, is the authority having jurisdiction, and that's going to be up to the authority having jurisdiction to determine what nearest the point of entrance means. And the code is written intentionally like that to allow you, the AHJ, to make a determination based on what your eyes are looking at out in the field. Now, when I was the chief electrical inspector for Garland, Texas, which is a suburb of Dallas, for a number of years before I went to work for IEI, there were quite a few places like this in the code book. We were enforcing the NEC. And at 23070A1, we didn't write an ordinance on this, but it was our policy. As the chief electrical inspector, I wanted the electrical contractors in my jurisdiction to get the same interpretation from an inspector in the north side of town as they would get in the south side of town. So as a department, we looked at 23070A1 or E3601.6.2 here and said, in our jurisdiction, nearest the point of entrance for this service disconnecting means is going to mean. Now, before I say this, if any of you write this down, I'm going to come visit you and tear your paper up or something, because what I'm getting ready to say is not code. It was my interpretation for the 19 years that I was chief electrical inspector for the city of Garland, Texas. We looked at this rule here where it said that the service disconnected means had to be located outside the building or inside nearest the point of entrance. And we determined that nearest the point of entrance in our jurisdiction was going to mean 5 feet. You could go up to 5 feet inside of a building before you had to locate a disconnect on the outside. And the whole reason for this rule in the code, and that's another thing, by the way, whenever you see a rule like this, I think it serves you best if you ask the question, why does that rule say what it says? Don't just, okay, I just accept that. The reason this says nearest the point of entrance here is we're trying to limit the length of an unfused service conductor inside of a building. In other words, it has no overcurrent protection ahead of it. So if we had a ground fault or something occur in that particular service entrance conductors, there would be, again, there's no overcurrent protection ahead of it to protect those conductors. So you try to limit the length of those service conductors inside of a building. And we determined that you could go up to 5 feet inside your building before. If you needed to go 5 foot 1 inch, then set a disconnect on the outside. And the reason, and when you set that disconnect on the outside, your service actually stops at the line side of that service disconnect, like you would see right here. And on the supply side, you'd have a feeder going into the building. And you can go as far as you need to go with a feeder because you have overcurrent protection ahead of that feeder. That overcurrent protection would be located right here. Now, you talk about a gray area. At the same time that in Garland, Texas, for those 19 years I was the chief there, where we said 5 feet, the city of Dallas, which we were a suburb of, and we actually shared a border with the city of Dallas. And I mean, there were literally streets that on one side of the street you were in the city of Dallas, on the other side of the street you were in the city of Garland. And at the same time where we said 5 feet for this rule, the city of Dallas looked at this rule and said 100 feet. You could go up to 100 feet inside the building before they got worried about a service disconnect on the outside. So do you see a gray area here? Yes. Who's going to determine what nearest the point of entrance means? The authority having jurisdiction. I'm going to ask you guys about 100 questions today as we go along through this presentation. And every time I ask you a question, if your answer back to me is the authority having jurisdiction, you're going to pass the test at the end of the day. You're not going to have a test. But if we were, again, I'm going to ask that question all day. You know, when we come to one of these quote unquote gray areas, I'll ask the question, who's going to determine if this is a damp, wet, or dry location? It's the authority having jurisdiction. And again, the code is written intentionally that way to allow the authority having jurisdiction to make a determination based on what they're seeing out in the field. So yes, there are gray areas in the code, and I can make you a better inspector leaving this presentation today than when you came into this presentation if you'll just simply do one thing for me: embrace gray areas. Don't hide from them. One of the worst experiences I've ever had in my career was being a student in a class, and the instructor would not embrace gray areas. When we would get to one of those quote unquote gray areas, the instructor would just jump past it right quick and say, "Oh my gosh, hope nobody asked me a question about that." Well, that's not what we're going to do here. I mean, we're going to look at these gray areas and embrace them and discuss them so that we can get some semblance of consensus interpretation for some of these rules. Okay. Here's another gray area right here. Now, if you look in your code book at E3706.1, don't look at it. Just take my word. It's in the code. It tells us, there's our code rule right there in yellow. Dogs must be on a leash. That can't be any more plain than what it is. Have these two knuckleheads met my code rule? Those two dogs right there. I can't tell you how many times as an electrical inspector I saw that look right there on an electrician's face. You know, what are you going to do with this big boy? And his helper with that ass-eating grin on his face, you know. So yes, there are gray areas in the code, and when we come across those gray areas today, I'm going to refer back to these two dogs here and say, you know, how would my two dogs handle this, you know, type of thing. So, and there's our target today. That's where we're going to spend our time today. If you have an electrical background like myself, for some reason, coming up in the electrical industry, there was kind of a division between a commercial inspector commercial electrician and a residential inspector or residential electrician, and somehow along the way I think we lost our way, because the residential guys kind of they're seen as something less than the commercial guys, and oh my gosh, could I disagree with that anymore? That is so false. Now, of course, Part 8 of the IRC covers electrical, but and residential requirements is what it focuses on. But if you were to look at like the National Electrical Code, where it covers all types of electrical installations, commercial, industrial, hazardous locations, and so on. If you were to look at the National Electrical Code, there are more specific requirements pertaining to a dwelling unit than if you took every other occupancy discussed in the National Electrical Code. We're talking warehouses, churches, office buildings, auditoriums, you name it. If you took the specific requirements for those other occupancies and combined them, it would reach about a third of the specific requirements pertaining to a dwelling unit. In other words, there are more specific requirements in the National Electrical Code pertaining to a dwelling unit than any other occupancy, and it's not even close. So I don't think we can put less emphasis on residential than we do commercial. I think both of them are just as equally important. This right here, guys, is where we spend the majority of our time. It's where our families live. Our grandchildren are in these occupancies right here, our children. So why would we not want to put a massive importance to the electrical requirements here? If we spent the majority or the remainder of our time that we're going to have together today here, and we did nothing but look at definitions, I would do you a favor. I really would. But boy, would that kind of get boring after a while. So we're not going to do that. But I wanted to point out how important definitions are. In just a little while, we're going to look at AFCI requirements, arc fault circuit interrupter requirements. And when we get over there, it's going to tell us that we need AFCI protection on the entire branch circuit that serves outlets or devices in bedrooms, living rooms, so on. A big list of rooms in a dwelling unit. Well, how are you going to even start to enforce that rule if you don't know the definition of an outlet? We got to have AFCI protection on all branch circuits that supply outlets in bedrooms. Well, if you don't know the definition of an outlet, you're behind the 8 ball to begin with, right? So I just can't stress enough how important definitions are. An outlet is any point along the wiring system where electricity is dispensed or disseminated to a piece of utilization equipment. And I can just give you an example after example after example of things like that just stress the emphasis of importance on our definitions. Let me give you an example of our definitions and how important they are. And by the way, guess what else you see sometimes in your definitions? You got it, gray areas. In the electrical code here, IRC or NEC, either one, you have 3 locations that you're going to find yourself in. And I don't care if you're at a dwelling unit, a hazardous oil refinery, a 50-story office building. I don't care where you're at. You're going to be limited to 3 locations and 3 locations only. You're either going to be in a damp, wet, or dry location. There is no moist location according to the electrical code. You're either in a damp, wet, or dry location. Now, here's your first question of your test here today. Who's going to determine which location we're in? There you go, everybody. It's the AHJ. Now, hopefully the AHJ will use these definitions out of Chapter 35 or out of Article 100 in the National Electrical Code to make a determination as to where you're at. The first one we see here is a damp location, and that tells us that in those locations, we're going to be subject to moderate degrees of moisture. In the National Electrical Code, it even gives us an informational note and gives us some examples of where a damp location might be. Locations under a canopy, marquees, open roof porches, places like that. When we used to travel, and hopefully we'll get back to that at some point, but I used to stay in a lot of hotels, traveling and doing these training presentations. And a lot of times I would pull up to a hotel and they'll have a canopy or a drive-through, where you can pull your car up. If it happens to be raining or something like that, you could pull up under that overhang and unload your luggage and things like that. And it's just my nature. I can't help it because it's my business. I just, anytime I get in an area like that, or a restaurant or wherever I'm at, I'm always looking around for code compliance, code violations, things like that. And I can't help when I pull up under one of those overhangs there at a hotel, I'll look up and say, that's a damp location right there. That's a wet location right there. Those type of things. And there's some places up under that overhang that I would consider a damp location if I were the authority having jurisdiction. And then we look at the next location, a dry location, and that would be a location not normally subject to any dampness or wetness. And man, whoever came up with this definition, I think they hit this one right on the head. I like that term, not normally subject. How many times have you seen on the news when a hurricane comes through an area, and you'll see places, buildings that are normally not subject to any dampness or wetness, but yet during that hurricane, there's water 5 feet up on the wall. So yeah, I think they kind of nailed that definition right there. Locations not normally subject to any dampness or wetness. I'm looking on the screen here at some of y'all's photographs here, and they are and images, and looks like a lot of you are at your house. Some of you are at your office. I happen to be at my office today, and if I were the authority having jurisdiction, my office here, for instance, and I look around at some of the pictures on your screen there, but my office here in particular, if I were the authority having jurisdiction, I would determine that this is a dry location. It's a location that's not normally going to be subject to any dampness or wetness. Now, here we go again. Who cares? Well, depending on what the authority having jurisdiction rules, it would determine a lot of things, like what type of wiring methods can I use? If I'm the authority having jurisdiction and I determine that we're in a dry location, well, wow, your wiring methods choices are wide open. I mean, you got a lot of choices. But what if I called this a damp location? Well, you still have some options, but not near as many as, the dry location. And if I were to rule that my office here is a wet location, well, you'd be limited to about 4 wiring methods at that point. Wiring methods that are identified for the environment. And speaking of a wet location is going to be subject to direct saturation with water. We're talking about dwelling units today. So an example that I can think of right there would be perhaps the disconnect outside by your air conditioning unit. Now it would depend on the overhang. I'd have to see the overhang and that type of stuff, but chances are highly, highly great that the AHJ is going to rule that to be a wet location. And so that disconnect would have to be what? Have to be identified for a wet location, a NEMA 3R type disconnect. The wiring method that we chose from the disconnect to the air conditioner itself, the unit itself, would need to be identified for a wet location. The conductors inside of that wiring method would have to be identified for a wet location and so on. So we've got three choices here, either a damp, wet, or dry location. All of them are defined in the code for us. And now we need to go put these into practice. So we find ourselves standing in the backyard of this particular dwelling unit, getting ready to do an inspection. And we've got a receptacle right here. See that receptacle right there? Let me blow it up for you where you can see it. I've got a receptacle right here. Now, we need to determine, you as the authority having jurisdiction, we need to determine, is this a damp, wet, or dry location? I suspect greatly that most of you would rule out a dry location pretty quick, but I bet we could get a pretty good discussion going on as to whether or not this is a damp or a wet location. Now, remember my two dogs this morning. Technically, that receptacle is located up under this porch, this overhang right here. Excuse me. So based on that, we could lean toward a damp location. Let me ask this question. Here we go again. Who cares? Keith, why are you wasting my time with this? It would matter what the authority having jurisdiction says, because this cover right here that is currently sitting right here, that cover for that receptacle is only identified to be used in a damp location. If the AHJ determines that that's a wet location, then that is a code violation right there. That's why all this stuff matters. If you look at E4002.9 in the IRC, that's going to be like 406.9B, I believe, in the National Electrical Code. It would tell us that in a wet location, you have to have a cover for a receptacle that provides weatherproof protection, whether or not a cord cap is plugged in or not. In other words, the in-use cover, the bubble cover, we call it out in the field a lot of times, and that cover right there is not identified for a wet location. Now I got to tell you, if I'm the AHJ, I would consider this a wet location right here, even though it's technically under this overhang right here. I still think this receptacle is subject to driving rain and snow, subject to moderate degrees of moisture. So I would determine that that's a code violation and you need a in-use cover right here. What if we just, that receptacle is not there, but it's located right there. Now we're way back under that overhang right there. Now what would you determine that to be? Would it still be, now could we use this flap cover right here? If I'm the authority having jurisdiction, I still think that's subject to driving rain and snow. I would still consider that a wet location. Does that make me right? Well, it does today because I'm the instructor, right? No, here's my point to you, ladies and gentlemen. Somewhere, maybe like right there, there's a line of demarcation between a damp location and a wet location. Now, your line of demarcation is going to be 3 feet from mine. Carla's line of demarcation is 2 inches from where mine is. Jamie's is 5 inches from where my line of demarcation is. Who's going to determine that line of demarcation? The authority having jurisdiction. So yes, even in our definitions, you're going to find some quote unquote gray areas like this that you're going to have to make a determination on. What about that luminaire right there? If I were the authority having jurisdiction, I would determine that that was a damp location. I do not think that one is subject to driving rain and snow, subject to moderate degrees of moisture, or direct saturation with water, but I do think it's going to be subject to moderate degrees of moisture from condensation alone in this outdoor area like this. So as the authority having jurisdiction, I would be looking for a label on that luminaire right there saying that it is identified for at least a damp location, a damp or a wet location. So yeah, all that matters. There's that in-use cover I was talking about. If that were to be determined to be a wet location, we would need a cover that provides weatherproof protection, whether or not a cord cap is plugged in or not. And an in-use cover, an outlet box hood cover is the technical term for that right there. We talked a little bit about that service disconnect a while ago when I was trying to give you an example of a gray area. And of course, if we're going to have service at a or electricity at a building, we're going to have a service, and a service disconnecting means it has to be located in a readily accessible location. Here we go again. How are you going to enforce this rule here if you don't know the definition of readily accessible? That's a defined term in Chapter 35 and in Article 100 of the National Electrical Code. You know, there's two similar definitions. One is accessible and the other one readily accessible. Now, accessible means like a junction box above a drop ceiling in my office here. That's required to be accessible. In other words, I could get a ladder, climb that ladder, remove a ceiling tile, and gain access to that junction box right there, and that would be perfectly within code. But whenever something says it has to be readily accessible, now that means I have to be able to walk right up to that piece of equipment and gain access to it without having to remove part of the building, without having to climb over or climb under something, without having to resort to a tool to gain access to it. Again, a panel board. The overcurrent devices in a panel board are required to be readily accessible. I need to be able to walk right up to them and gain access. And so is this service disconnecting means right here. Required to be located in a readily accessible location. As we talked about, it can either be located outside or inside the building. But if it's located inside the building, it has to be in that, quote, nearest the point of entrance from where the service entrance conductors enter the building. If we went underground, for instance, we went under the slab, the meter base is sitting on the outside of the house or something, and then we went out of that and went underground and went under the slab. And at some point we turned that raceway up and started coming into the building. We penetrate the slab and then go up into a panel board or something. Our quote unquote nearest the point of entrance would start at that slab, because the code tells us that anything under 2 inches of concrete or under 18 inches of earth is considered outside the building. So when we start taking our measurement for something for these service disconnects nearest the point of entrance. Now, if we set a disconnect or a meter base on the outside of the house and then go directly out of the back of that meter base through the wall into the, of course, that's where our nearest point of entrance is going to be measured from. And as I was discussing there, if the raceway, the service raceway is located under 2 inches of concrete, and a typical residential slab is what, about 4 inches thick, or if we're encased in 2 inches of concrete, if we're under 18 inches of earth, then all of that is considered outside the building, and we would have to start our or we would be allowed to start our measurement from that nearest point of entrance where we penetrated the slab right there. And this is one of those first places where we see the NEC default here, that the IRC doesn't give us these provisions for what's inside the building or outside the building. So we would have to default to the NEC right here at 230.6. Here we see a disconnect for a dwelling unit. Typically the utility company will provide a point of service, typically that meter base in this case. And now I took this photograph years ago, and you see that brick wall right there, the outside of the dwelling unit. On the other side of that wall right there is the master bedroom. Now, the installer, the builder, the homeowner, probably a combination of those, they could have chose to come directly out of the back of that meter base, nipple into the, a back-to-back situation where you got about 7 inches, about a 7-inch nipple there from that meter base, and they could have put a panel board, their first means of disconnect with a main breaker in it, on the back side of that meter base right there, but the panel board would be located on the wall in the master bedroom. And of course, you'd have to maintain proper working space and so on about that thing. So, somebody made the decision and said, no, we're not gonna do that. Instead, what we're gonna do is we're gonna go ahead and set our service disconnecting means on the outside of the building. And then we're gonna run a feeder, through the building, maybe over to the other side of the building to the garage, and we're going to locate a feeder panel board, a sub panel board, if you will, in the garage, fed with a feeder. And my nearest point of entrance doesn't apply here because my first means of disconnect is located outside, and my service stops on the line side and a feeder begins on the load side here. And I can go as far as I need to go inside the building because I have overcurrent protection ahead of these conductors that I'm running inside the building to something like this right here, where you have a feeder coming in, first means disconnect, and then your overcurrent devices and so on here. Now, again, the overcurrent devices, you got to be real careful right here because we're talking service disconnects and we're talking dwelling units, and chances are pretty great. It doesn't have to be, but a lot of times at a dwelling unit, you'll see you'll see a panel board with a main breaker in it. And that serves as that quote unquote first means of disconnect. And a lot of times people will call me because, and we have rules that tell us that we cannot locate overcurrent devices in the vicinity of easily ignitable materials such as a clothes closet. We can't locate the overcurrent devices over a stairway. We can't locate them in a bathroom. And a lot of times people will call me and say, Keith, man, I know I was in one of your classes or something, and I remember you saying that a panel board can't be located in a clothes closet. Well, and I can't find that in the code. Where is that? Well, the reason you can't find that in the code is because the code doesn't say that. What the code says is overcurrent devices can't be located in a closed closet. Literally, remember my 2 dogs this morning? I could locate a panel board in a closed closet all day long. What I couldn't do is put any overcurrent devices in that panel board, which why would you want to do that? So you got to be careful with what you're looking at or looking for when you start looking in the electrical code, trying to find some of these rules. And this one is specific to overcurrent devices, not necessarily the cabinet that contains the overcurrent devices. So no, we cannot, at a dwelling unit, we cannot locate a panel board. Boy, here I go. I just said the opposite of what I just told you, didn't I? We cannot locate overcurrent devices in a bathroom like this. They have to be located in a readily accessible location. We could put it right out here on the wall of the hallway or something like that. We would have to maintain working space if we chose to do that. That's why most people will go ahead and put a disconnect on the outside and then run a feeder inside and then run and locate your overcurrent devices like in a garage, the wall of a garage or something. And again, you got to maintain working space in those areas as well.
I have a question. Okay.
Go ahead.
In your last slide with the overcurrent devices in the bathroom, I've had to make a decision because I've had that presented to me what they need to do and in an existing condition, and I've had them encapsulate it and make it weatherproof. Was that a good decision?
No. Now you have a code violation that's been weatherproofed.
Okay, so it's not, I've actually had this, for some odd reason, people have put the service panels in their bathrooms around here, and I'm not sure why.
Code violation.
I understand that, but it's been accepted, and it's not accepted by me.
Yeah.
But some of the houses are very old.
Yeah.
They can't move them.
Well,
so trying to find a way to separate it. So
well, that rule right there in the National Electrical Code at 240.24 and 230.78 there, those haven't been in the code forever. So if you've got a dwelling unit that's 50 years old, 60 years old, it might have met code at the time it was installed. Mm-hmm. But under today's code, then no, they cannot be located in a bathroom. Sometimes people will call me and say, I'm going to locate my overcurrent devices, my panel board in a closed closet, but I'm going to build a little enclosure around that panel board. It's still in a closed closet, whether you wrap it in toilet paper, it's still in a closed closet, and that's a code violation. So
I made a 2-hour assembly around it.
You have a code violation with a 2-hour assembly around it.
I got it. All right.
Thank you.
We even have those things in kitchen cabinets on the older houses.
Yes.
Yeah.
And it's an existing, and it met code when it was done. There's not a whole lot you can do about it unless they're doing a lot of extensive work to that building.
Yeah, something like that. Now, something like that, you know, cabinet or something, I think that no matter how old it is, I think that would probably still be a code violation because the working space requirements
Right.
that you have to maintain around equipment like that has been in the code since Moses was around. So,
Then you gotta tell the people to rip the kitchen cabinets out.
or,
Not all
or
of them, just one,
Just that one.
just that
Yeah.
one.
And remove the jar of pennies next to it.
yeah,
Yeah, that's right.
we have to properly mark service disconnected means. It has to be identified by the manufacturer that it's suitable for use as service equipment. Have you ever heard the term SUSE rated? That's what that means, suitable for use as service equipment. And the manufacturer will mark their equipment as either suitable for use as service equipment, suitable only for service equipment, suitable for use as service equipment when not more than 6 mains are installed, something like that. A lot of times you'll have a panel board where the manufacturer actually provides a bar that can be removed, and that bar, attaches to the grounded terminal, the intentionally grounded terminal, your neutral conductors, and the other side attaches to the grounding, ing, equipment grounding terminal bar. And if you're going to use that as service equipment, then you would leave that bar in place. But if you were using that as a feeder panel board where you have to isolate your grounded conductors from your grounding conductors, and we'll get into that later, you would actually remove that bar. And in a case like that, I promise you what you would find is a label saying that it was suitable for use as service equipment. You would not see that label right there saying suitable only for use as service equipment, because the manufacturer makes it to where you can use it either or by simply removing that bar and so on. We have to have our, of course, like I talked about, that the service disconnect has to be suitable for use as service equipment. And again, you're going to see a label typically on the inside of a panel board lid, or a lot of times you'll see it on the inside of that cabinet right there, and it'll say something like that right there, suitable for use as service equipment, or something similar to that right there. Your service disconnected means have to have a permanent marking on them, identified as a service disconnect. The manufacturers do a real good job right there helping us meet this code requirement. A lot of times they will provide a label that we can put on a piece of equipment like that one right there that will help us meet that code requirement right there. If we're going to use that disconnect right there as service equipment, we can put that label on and say yes, this is a service disconnect. One thing I forgot to tell you at the beginning of this presentation. One thing I did do, this presentation is based on the requirements of the 2018 IRC. The 2021 IRC has just been published. That coincides with the 2020 National Electrical Code. And so, I don't know, 8 times, 10 times or so throughout this presentation, I did put in some slides that talk about a change that's coming to the code that you probably need to be aware of. Now you're going to easily be able to recognize these. This is not going to be part of, it's not going to be part of the material that you downloaded of that electronic version of that book that we produced. But I did want to give you a heads up that there are some changes coming that you need to be aware of. And one of them is right here. at E3606.5, which is 23067 in the National Electrical Code, we have a new requirement coming that's going to require whole house surge protection for dwelling units. And this surge protection has to be located at service equipment of a dwelling unit. It has to be an integral part of your service equipment, or it can be immediately adjacent thereto to your service equipment. That look like a gray area there. What does immediate adjacent mean? Does immediately adjacent mean 4 inches, 2 inches, 1 inch? Who's going to determine what immediately adjacent to the service equipment is? The authority having jurisdiction. Our surge protection has to be either a type 1 or a type 2 surge protection device. They make about 4 different types. Type 1 or type 2 is what this one was required to be. This also applies to replacement of service equipment. In other words, if you go to grandma's house that's 40 years old, 50 years old, and you upgrade the service at grandma's house, and the local jurisdiction is enforcing the 2020 NEC or the 2021 IRC, you would need to go back with that new service, would have to include this whole house surge protection right here. Lots of the manufacturers of service equipment panel boards, your Eaton's, your Cutler Hammer, GE, every one of them. Gosh, I just went blank with the rest of the panel board manufacturers there. But anyway, every one of them, because of this rule, and typically in the electrical industry, particularly when we provide the manufacturers with a code requirement, when we provide the manufacturers the opportunity to build a better mousetrap, they typically step up to the plate and build a better mousetrap, particularly if there's money to be made at the end of that rainbow. And so every major manufacturer, Siemens was the one I was trying to think of, all of them have come out with a panel board, a residential panel board that has built-in surge protection device right in the panel board. It'll be located like right there. Or you could buy a external surge protection device that's located where? Immediately adjacent to the service equipment right here. But that is a change coming in the next edition of the code, and I just wanted you to be aware of that right there. We talked a little bit about working space when we're talking about service equipment, panel boards in particular. We have to talk about working space, and it's a dimension of space, a cube of space that has to be maintained in front of a piece of electrical equipment, such as a disconnect or a panel board or whatever it might be. There's actually 2 spaces that we have to concern ourselves with when it comes to space about electrical equipment, around electrical equipment. One of them is working space and the other one is dedicated electrical space. And those are 2 completely separate spaces. In the purple right there, you see depicted the dedicated electrical space. Now we're looking at a disconnecting means right here. It looks like a surface mounted disconnecting means or something. And we're looking at 2 views. We're looking at a front view and a side view. And the dedicated electrical space is again that space depicted in purple right there. And it's actually the signature of that piece of equipment. In other words, if that disconnect right there were 9 inches wide and 3 inches deep, you would have a 9 by 3 cube of space above and below that piece of equipment that is dedicated to the electrician, to the installer, to get branch circuits and feeders and whatever else in and out of that piece of equipment right there. The plumber can't run a gas line in that purple space right there. The mechanical guy can't run a mechanical duct and part of it penetrate that purple space right there. That would be a code violation. And again, that purple space, it belongs to the electrician. It's a space that it goes up above that, whatever piece of equipment that is. It goes up to 6 feet above that equipment, or the structural ceiling, whichever comes first. Now, at a dwelling unit, if you have a sheetrock ceiling with 2x6 rafters or whatever above it, floor joist, ceiling joist above it, that would be your structural ceiling. And so if that structural ceiling was 3 foot 2 inches above this disconnect, your dedicated electrical space would be a 9 by 3 cube of space that goes 3 foot 2 inches above that, or 6 feet, whichever is greater. If this were like in my office here where I've got a drop ceiling above me, that drop ceiling is not structural ceiling, and so the 6 feet would actually go above that drop ceiling like that right there. And it goes below that piece of equipment to the floor. And in the yellow there is what is depicted as the working space right there. And these are two completely separate spaces right here. A lot of times I'll see an inspector that will misinterpret the code, and he'll try to encompass this area right up here and try to make this all one big space that belongs to the electrician. And no, this your dedicated space is that signature of that piece of equipment, and your working space is a space out in front of that piece of equipment that has to be maintained. We have a table at 110.26a in the National Electrical Code. Now, there's not a table in the IRC because it only addresses these one conditions that you typically find at a dwelling unit. But in the NEC, that table has 3 conditions. If you have live exposed parts on one side, which would be your panel board and overcurrent devices, and live exposed parts on the other side. In other words, you got a panel board facing a panel board facing a switchgear or something like that in an electrical equipment room, then your working space is going to be greater. And it also depends on the voltage involved. There's a break that I believe it goes from 0 to 150 volts to ground, and then 151 volts and higher would all determine the depth of that working space, from the front of that piece of equipment out. And then you have another condition that says where you got live exposed parts on one side, the panel board, disconnect, whatever it is, and you got grounded parts on the other side. You've got a panel board facing a haydite brick wall, something like that. That would probably increase your depth of that working space. And then the third condition talks about you got live exposed parts on one side and no grounded or live exposed parts on the other side, typically what you would find at a dwelling unit, particularly if your panel board is located out in the garage there. And the code in that case would call for the depth of your working space to be 3 feet, a minimum of 3 feet. It's always going to be 30 inches wide, or the width of the equipment, whichever is greater. And it's going to be 6.5 foot in height. As I said, you know, a lot of people will try to take into this space right here. And I had an inspector that worked for me one time that was misinterpreting this, and he was trying to keep the plumbers from running stuff up in this area right up here. And so one day my wife and I had bought a new refrigerator, and you know how you do a refrigerator. I got a razor knife and, you know, cut around the bottom of it, and you just lift the box off of the refrigerator, and we installed the new refrigerator. And as I was cleaning up, I looked out in my driveway and I had a big old cardboard box out there. And boy, I got to looking at it, and it was about 36 inches deep. It was about 30 inches wide, and it was about 6.5 feet tall. And so that Monday morning, I called that inspector and told him to meet me at my house. And I put that big cardboard box in front of my panel board there in my garage. And, you know, I said, now do you see that working space? You know, it's not that space up here. It's just this area right here that's about the size of a refrigerator box. And he finally got it. You know, he was a very visual learner, and, you know, it finally clicked with him. So being a good supervisor, I told him to load that cardboard box up and take it to every job site he goes to. And, you know, but no, I mean that made a good analogy for all the inspectors. You know, they'd come ask me, hey, I got a working space problem, and I'd listen to them. And then I would just look right at them, and every time I'd say the same thing. Can you put Eric's refrigerator box in front of that piece of equipment? Well, no, because there's a gas meter or something there. Well, then you got a working space problem. And again, your working space is required to be 30 inches wide, or the width of the equipment, whichever is greater. So in other words, if you had 3 panel boards lined up here, your working, and these spaces can overlap each other. So your working space in this case would be from that corner right there to that corner right there. But if you just have a single panel board like you typically do at a dwelling unit, you just need that 30 inches wide, typically 36-inch deep space, 6.5 foot tall. And a lot of people will try to tell you that 30 inches needs to be centered on that piece of equipment, and that's not true. That's a misinterpretation of the code. I just need, you know, even if you put it in the corner, I need 30. If you can give me 30 inches, 36 inches, 6.5 foot tall, we're good to go. You probably would have to hope that your electrician's left-handed in this case right here, but that meets code right there. Now we're talking service equipment right here in this particular part of the presentation, but actually, where do you need working space? The code says we need working space at any piece of electrical equipment likely to require examination, service, adjustment, maintenance while energized. Now, I'm not sure which piece of electrical equipment I just left out. So in other words, yes, we need working space on these AC disconnects right here. And I think these AC units are violating the working space of their own disconnects right there. Yes, I have a piece of electrical equipment right here that requires working space, both of these. Landscaper came along and put a little old tree, little bush right in front of that panel board. Everything's great and lovely right now, but 18 months from now, what's this going to be? You're going to have a machete to get to this panel board right here. That's a working space issue right here.
Hey Keith, I have a question when you have a sec.
Sure.
So one of the challenges I've run into in the field quite a bit for some reason is, you know, the utility company, when they set that meter, at least here in California, they have what they call a green book, where they want distance on either side of the meter as well as in front of the meter, right?
Mm-hmm.
And the challenges that I've been running into is, as building inspectors, you know, we kind of know what PG&E wants, but some of my fellow counterparts don't seem to care, or it's not that important to them. So then they approve the installation like you see right there, PG&E would take a issue with it here and they would deny it. And we've had that happen, especially in my current situation. We had a poor homeowner had to come in and get 3 permits because our inspector basically said, not my problem, you know. And do you find that that's kind of common, or do you
Yes,
feel that as inspectors we should be, you know, you're supposed to be working for the citizen, right? Doing what's
I
best for
agree.
the citizen, not
I
for
agree.
yourself.
Whenever I go out and gather photos that you're seeing in these presentations here, um, I can't tell you how difficult it is to take a photograph. And this is a sad commentary on our industry, what I'm getting ready to say. But I can't tell you how hard it is to go out and take a photograph with no code violations in that photograph. And yeah, I mean, working space is a code requirement. And then, like you talked about, you're going to have utility companies that have their own local requirements, and I mean, you might as well look at that as a it's not a code requirement, but it's almost like a local ordinance. You know, if you can't ignore it, if you want a meter in that meter base, you're going to have to comply with those rules. And so, yes, those do need to be addressed by the local AHJ. You know, dang it, I hate it. I hate to say this. I hate it, but I have to say it all the time. In the case you just described, Jamie, there, the local inspector has just as much right to be wrong as the next guy. And in this case, he was. You know, and I wish that weren't true, but that's what it is. And to me, that's a clear violation of that local ordinance, and it's a clear violation of the National Electrical Code if you don't enforce working space around equipment like this. Let's go ahead and take us our first break. Y'all ready for a break here? I'm going to let me put up a clock for us, and that'll help us get back in the room. Let's take about 10 minutes, and I'll see you guys in about 10 minutes.